Hello everyone, my name is Tamilselvan son of Ganesan from 4BEA 1/2, Department of Electrical Engineering Technology, Faculty of Electrical and Electronic Engineering Technology. So today I would like to present about my final year project, which is development of carbon monoxide detector by using IoT technology. First of all, I would like to thank to my supervisor who really helped to complete my project. Her name is Dr. T.S. Dr. Sahasati binti Muhammad Rosali. Okay, let me begin with my project description. Since there are many cases on sudden death in the car due to the carbon monoxide leakage, this project proposed to develop an equipment that can detect the gas leakage and give an indicator to the user. Introduction. What is carbon monoxide actually? So basically, carbon monoxide is a colorless, tasteless, and toxic gas to humans. It is usually the result of unhealthy combustion, and it's a great threat to human health. Unhealthy combustion means it's something like incomplete combustion of the car engine or some open burning or charcoal burning, something like that. So it's mainly from the incomplete combustion of the. So as we're talking about in its vehicle, so we can say about it's a incomplete burning of the oil in the engine. So the CO has made many intoxication victims in the world in recent years. Therefore, researchers investigated many materials using several methods and techniques to detect these gas and commercialize them in the form of CO sensors. Okay, the problem statement. The problem statement behind this project is first of all is sudden death cases while sleeping in car as raised among the Malaysian. Malaysian normally when they travel to long drives they normally park their car in the most likely in R&R, which is the rest place, so they will sleep for a while. The next is the exhaust gas leakage is contaminated in the car passenger compartment, especially for car that has been not well maintained. The carbon monoxide gas leakage are hardly traced by drivers. As I mentioned above, it's a colorless. That's why we cannot trace the carbon monoxide gas by normal human eye or human nose. So the absence of an addition tool to detect the presence of carbon monoxide gas is a big issue and its application is seen as unimportant. Okay, the main objective of this project is to develop a system that can detect the presence of carbon monoxide gas leakage in the car. The second objective is to monitor the concentration of carbon monoxide gas using IoT system. Okay, the second objective, how it works is, this project is created with MQTT platform where the real-time data of the carbon monoxide reading will recorded recorded in the MQTT public server, so that when the manufacturer want to check our car's problem, so they can easily detect the whether our car got carbon monoxide leakage or not. So it's easy for them to do the maintenance of the car. So the third objective is to analyze the concentration of carbon monoxide gas at different time steps in different environment and place. So the third objective is this project has been tested in two locations at two different times. So first location is in underground parking in a mall, and then it's a petrol station, and on sunny day and then night time. So we want to differentiate the carbon monoxide level in daytime and also in nighttime, and also in a closed area and unclosed area in open area. So that's how the analysis of this project has been carried out. Okay, next is the flowchart and methodology of this project. So this one is the methodology. The methodology means how I start the project and how I end this project. So first of all, the simulation of this project has been set up. So the simulation is I'm using the Proteus software and Arduino IDE to draw the circuit. Second is hardware setup. So when the simulation setup is complete and tested, now move on to hardware setup. So the circuit has been connected manually. The main microcontroller of this project is VMOS D1 Wi-Fi Uno ESP8266. So it's a Wi-Fi module that can easily connect through Wi-Fi and has many functions. So the final step is MQTT and IFTT setup. MQTT is just now, as I mentioned just now, it's a real-time data recording for through the MQTT platform, and then IFTT is to send SMS through IoT technology also. So later on I'll explain more. Okay, so this is how the prototype of my project works. So first of all, initializing. So when we When we connect the power to the prototype, so it will show initializing, and then the LCD display shows this reading of the carbon monoxide in ppm. So when at the same time when the system is on, the MQTT will record the real-time carbon monoxide data reading in background. So from the system start to the system end, the MQTT will record all the data for every second, each and every second. Okay, next is, so when the sensor reach the threshold value, it means for this project I have set the threshold value to 20 ppm. So when the analog sensor reach the threshold value, so the LED and buzzer will on, the LCD will shows CO detected. So when the LCD and when the sensor detect the CO carbon monoxide leakage, so at the same time an SMS sent to the user with the with the location where is the data. To track the location, I've used the GPS Neo 6M module. So in the SMS, it will shows the date and time and also the latitude and longitude of where the CO is detected. So the final step is the user F2 alert. So when the user see the LED and the buzzer and then the LCD display, they should alert about the carbon monoxide detection. Okay, now as we move on to the result and analysis. So this is the prototype of the carbon monoxide detector. In this prototype, we can see a MQ7 analog carbon monoxide sensor. This one is the LED indicator. This one is the buzzer, and this one is the LCD display. So as you can see over here, it shows CO sensor and then the level of ppm, and then it will show CO detected when it's reached the threshold value. So for this picture, I have burned some charcoal in front of the analog sensor, so it detected. Okay, as the analysis part, as I mentioned earlier, so this prototype was tested in two locations, which is underground closed parking and a petrol station during daytime and nighttime. So according to this graph, during daytime, the concentration of carbon monoxide level is higher, which is reached until 14 ppm in daytime, and in nighttime also it's in the same location, where at underground parking it's reached until 11 ppm. So according to the analysis of these graphs, we can say that the concentration level of carbon monoxide gas is higher at enclosed location compared to open environment. So from this chart we can say that in underground parking, the concentration level of the carbon monoxide gas is higher compared to the petrol station, which is in open area. So this how this analysis is tested actually. Okay, this prototype has been placed in the car dashboard. So the for the daytime, the concentration was recorded from 12 p.m. until 2 p.m. and for the night time, the concentration recorded from 8 p.m. to 10 p.m. The reason for daytime 12 p.m. to 2 p.m. because I plan to record the data on peak hours so that we can know where we can get more cars in the enclosed parking area as same as the petrol station. So that's the analysis of this project. Okay, next is project features. So what are the features in this prototype? So CO gas leaks can be detected early. So according to the prototype, we can early alert and early warnings through the LED and buzzer and also the SMS. The next is accurate alarm can detect accumulating CO levels and then send SMS to the user if user not alert. In case the user didn't notice the LED blinking or buzzer sound, so at least they have to alert by receive the SMS. Okay, novelty and inventiveness. So actually, what is meaning of the novelty and inventiveness is what is the extra feature or advantage of this project compared to all device that already in the market. So the device that already in the market, actually they don't have MQTT reading or SMS sending platform, but in this project we have created the SMS receiving through IoT platform, which is IFTT, and then the real-time data recording in MQTT public portal. So these are the two main advantages of this project compared to the device that already in the market. So they only got alert system which is LED or something like buzzer. That's all. Okay, the project potential of commercialization. This project has potential to earn attention if commercialized in the market because a smart alerting technique, small design that can easily keep in vehicles. So the design is something like a small box. It's lower in price and has accurate reading. So this project has been tested by burning some charcoals, by burning some papers, already tested in some locations. So from my observation, we can say that this product has a accurate reading. Okay, the conclusion part is at the end of this experiment, this project, the objective of this project has been achieved. Development of CO detector with IoT will reduce the risk of sudden death of human in car if the user is alerted by this device. Smart techniques has been used to alert the user in order to escape from carbon monoxide poisoning. An LED, buzzer, and LCD display will alert the user directly, while a SMS will also send with the location of the data. The MQTT is for real-time data record for the manufacturer of the leakage of carbon monoxide gas for them to make some maintenance works in the vehicle. As a conclusion, based on the graph update, CO detected higher at the underground parking since it is in an enclosed area compared to the open environment. So that's all for my presentation. Next, we'll move on to the demonstration of the prototype. So today I will explain how the carbon monoxide detector in vehicle will working. Okay, so this one is my prototype. So in here I keep a LCD display, buzzer, LED, and the MQ7 CO sensor. Okay, so this one is my roughly prototype. Okay, so now I already upload the coding in the system. Okay, this one is the serial monitor. So as you can see, it will show the location of the carbon monoxide detector. It shows in latitude and longitude. It will show the date, it will show the time, and then it will show the carbon monoxide level. So now it's in 6 levels, something like that. Okay, at the same time we can see in MQTT it will send the real-time data of the carbon monoxide level. So you can see here it shows CO sensor, the level, and then the location. Okay, so now we will do a demonstration over here. Okay, as you can see, the sensor value is increasing. So when the sensor reach the threshold value, the buzzer will start and then the LED will start to blink. At the same time we will receive a SMS in the registered phone number. Okay, so as you can see, it will show the sensor value and the location and the date and time. It will show the message CO detected, and in the MQTT portal also same. So it will show the CO sensor value, the location, and it will show a message CO detected. So that's how my project works. Thank you. Okay, that's all for my project, which is the development of carbon monoxide detector using IoT technology. So I hope you guys enjoy it. So thank you very much.